Hello everyone, I am Saram Prasad Bandi. I am going to present about partition problem today. Let's get started. While coming to the contents of the presentation, we are going to talk about the introduction, algorithm, application, and while coming to the introduction, partition problem is the task of deciding whether a given multiset S of a portion integer can be partitioned into two subsets S1 and S2 such that the sum of numbers in the S1 equals to the sum of numbers in the S2. The partition problem is NP complete. There is a pseudo polynomial time dynamic programming solution, and there are heuristics that solve the problem in many instances either optimally or approximately. For this reason, it can also be called the easiest hard problem. There is an optimization version of the partition problem, which is to partition the multiset S into two subsets S1 and S2 such that the difference between the sum of elements in S1 and the sum of elements in S2 is minimized. The partition problem is a special case of two related problems. In the subset sum problem, the goal is to find the subset of S whose sum is the certain target number T given as input. The partition problem is the specific case in which T is half the sum of S. In multi-way number partitioning, there is an integer parameter k, and the goal is to decide whether S can be partitioned into k subsets of equal sum. The partition problem is the specified case in which k is equal to 2. However, it is quite different than the three partition problem. In that problem, the number of subsets is not fixed in advance. It should be mod 3 mod s by 3, where each subset must have exactly 3 elements. 3 partition is much harder than the partition. It has no pseudo polynomial time algorithm unless p is equal to np. While coming to the algorithm, the complete greedy algorithm considers all partitions by constructing a binary tree. Each level in the tree corresponds to an input number, where the root corresponds to the largest number, the level below the next largest number, etc. Each branch corresponds to a different set in which the current number can be put. Traversing the tree in depth first order requires only order of n space, but it might take order of 2 power n time. The runtime can be improved by using a greedy heuristic in each level. Developing first the branch in which the current number is put in the set with the smallest sum. This algorithm finds first the solution found by the greedy number partitioning, but then proceeds to the look for the greatest solution. Some variations of this idea are fully polynomial time approximation scheme for the subset sum problem, and hence for the partition problem as well. Another process is the complete Karp algorithm. CKK considers all partitions by constructing a binary tree. Each level corresponds to a pair of numbers. The left branch corresponds to putting them in the different subset, that is replacing them by their difference. And the right branch corresponds to putting them in the same subset, that is replacing them by their sum. This algorithm finds first the solution found by the largest difference method, but then proceeds to find better solution. It runs substantially faster than the CGA on random instances. Its advantage is much larger when an equal portion exists and can be several orders of magnitude. In practice, problems of arbitrary size can be solved by CKK if the number has at most 12 significant digits. CKK can also run as an anytime algorithm. It finds the KK solution first and then finds progressively better solution as the time allows, possibly requiring exponential time to reach optimally for the worst instances. It requires order of n space, but in the worst case, it requires order of 2 power n time. While coming to the applications, on application of the partition problem is for manipulation of the elections. Suppose there are three candidates A, B and C. A single candidate should be elected using a voting rule based on scoring. Example, the vote rule, veto rule, sorry. Each voter votes a single candidate, and candidate with the fewest votes wins. If a coalition wants to ensure that the C is elected, they should partition their votes among the A and B so as to minimize the smallest number of votes each of them gets. If the votes are weighted, then the problem can be reduced to the partition problem, and thus it can be solved efficiently by CKK. This same is true for any other voting rule. This is based on scoring. Another example is given S is equal to 3 1 1 2 2 1. A valid solution to the partition problem is two sets S1 and S2, S1 with having 1, 1, 1, 2, and S2 having 2 and 3. Both sets sum is 5 and they are partitioned S. Note that this is a solution is not unique. The solution might be vary for the different subsets like S1 is equal to 311 and S2 is equal to 221 is another solution as their sum is still the 5. Not every multiset of the positive integer has a positive position partition into two subsets with equal sum. An example of such is a set of S is equal to 2 comma 5. Thank you. I'm concluding my presentation.